Hi everyone, this is Jan Daniel again, coming back after a week of scraping on my milling machine's column. Unfortunately, I was hoping I would have a lot of cool color map like this one to show you of this process, but straight from the get-go I run into an issue. I don't want to dive too much into the technical stuff of how these measurement devices work, but basically, let's just say that when I did my initial assessment, the machine was upside down and all the pieces like the tracker, the scanner, and the part that I was scanning, everything was properly lined up to give me the best accuracy I could get. And when I laid the machine on its back, I actually end up having data that was not repeatable enough for what I wanted. Simply because of the orientation of the part in regard with the scanner, in regard with the laser tracker. So I had already taken a week off work to work on this and borrowed the equipment and all of that. So I kind of had to make the most of what I could during that week. So I decided to switch gear and go to probing only using the reflector. This is a very accurate measurement system when you're only using the reflector, and you'll kind of see in the next minutes how I actually measured the part doing that, but I just wanted to do a quick intro of why I ended up probing the part instead of scanning it. The color map that you see here is actually from after my scraping process, so we'll talk about it more when I'm done presenting the scraping process. Okay, so I'm starting a new set of measurements, so figured I would kind of show you what I'm doing. Basically, the very first time I laid the machine on its back, I took some extra time to realign myself with what I did on the computer the other day. So basically, if you remember, I aligned myself to the spindle in that area, and I did a bunch of measurement of the gib and all of that. Once I flipped the machine on its back, I remeasured the whole thing, so I fell back into that same alignment. And then I shot all of these targets. I have some of these nests all the way around. I have one down here. So that way, every time I do a new set of measurement, I just reshoot these and I fall right back into my alignment where I know that my level plane is correct and all of that. Because basically, when I'm scraping, I could be pushing the machine around. It could be moving a little bit. And this is such a precise set of measurement that I need to make sure every single time I reshoot the measurement that everything is where it needs to be. So now I'm ready to gather some more measurements for this project. I am fully aligned like you just saw, and now I'm ready to actually measure my top surface. So I'm going to use one of these. It's what they call a flatness because it has obviously a flat bottom as opposed to this round thing. And I can kind of slide it around like that. It is magnetic too. It sticks to the surface. And the idea is that by using that, it gives me, kind of the average of the surface instead of reading all the little irregularities of the surface. So I'm gonna grab that, put it in its nest. All right, and now the machine is set in a mode where basically as I'm moving this, it's gonna continuously acquire point. So I don't know if you can kind of hear that, but the PC is making a click, and I'm just gonna go walk and show you. All right, so it's currently registering point wherever I slide this. All right, so I'm gonna go ahead and shoot the whole thing and show you the result after. Okay, so you can see that I have blued my part here. I'll probably end up showing a better photo on the computer as I'm showing you this, but so I'm measuring it with the laser tracker as well, and I'm correlating the data that I see on screen. So hopefully this comes out okay. So I'm correlating the data that I can see on screen. So basically on this color map, my high spots are the light greens. My dark spot, the black spots are kind of the average, and the dark green is lower than the dark spot. So here you can see that this whole bottom portion is high. I have a couple of high spots there and also here. But if I look at the top here, this is actually lower. So I will disregard any high spots that I have in this area on my blue marking, because I know even though they're coming out as high spots, they're actually on the correct height right now. So I'll focus mainly in this lower area, and then right, so if I go back here, so I'll focus in this area here. There's a couple of high spots here. I think this one is one of them, but everything here I won't touch. Also this I will scrape as well, because this is coming out as high on the color map. But yeah, so I'll keep on scraping and get back to you later. Okay, so quick update just to show you what I did. Here, this top corner was high, but you can see I skipped this whole area. I scraped. I'm still roughing right now, right? So I'm, scraping the paint off, as Richard would say. So I'm using a hand scraper, so I'm doing like fairly long and wide strokes. But basically I removed all the blue spots in these areas, but nothing up here because this is low, and this corner here is low too, so I didn't touch anything. So I'll brush the chips off, stone that pretty heavily, and rinse and repeat. We'll bring you along when I have an update that's interesting. Okay, so I want to show you something else, and let's pretend I want to see where that is. It's kind of hard, to locate it along the entire edge, that green point that's there. So if you look, that orange ball that you see here, it's currently where the reflector is on the part. So what I can do is I'll zoom on that area, and hopefully you'll be able to see this from far away. But right now, the laser tracker is looking at the SMR. So let me see if I can zoom in. Hopefully you can see that. But basically, you see I'm moving the SMR, and now I know this is exactly where that measurement happened. Okay, so I'm gonna zoom back. So then I would grab a pen and circle that area, and I know that this big high spot here is what's causing that green spot on the PC. So when I got to my 18th iteration, I decided to try something new, because I felt like I was kind of chasing my tails on some of these points. Sometimes they were a high point where they shouldn't have been one, or stuff like that. And I decided to, instead of probing discrete points like that, I probed what we call a surface point cloud. So I literally probed like thousands of points. And then I used that to project it on a CAD surface, and then that gives me the option to kind of average out the deviation, and that gives me kind of a more like macro scale view of what's going on instead of chasing points. And if you compare that to the probing session that I had in the same project, you can kind of see that I have a couple of really low spots in that area, but overall it's just because, the SMR happened to be right in that spot. Or it could also be variability, because I'm, as I'm moving the SMR to probe this, I could be slightly lifting it up, or, having some imperfection in my technique or my movement. But because now I probed like literally thousands of points, I think I have, let me check this out, like 7,500 points. The software is able to average out all of these deviation and basically create more of an average color map that's more useful for me when I'm scraping. So I went from this, and now I focused on the pink areas, which were my high spot, to 19. You can see most of the pink is gone. Only a couple of high spot in these areas, and then I went to 20. And, I went pretty aggressively on that pass, and you can see the whole surface dropped here. But, everything is in between minus 3.5 tau or 4 tau. So at this point, I started to feel like I was getting pretty flat. And in order to verify myself, I decided to, again, try something else, just to confirm that at this point I was getting pretty flat. So on top of my straight edge, I also have a small granite surface of 24 by 18. And this is pretty unorthodox. I've never seen or heard about someone doing that, but I figured there was probably nothing wrong with it as long as I was careful. So what I did is I marked the top of my granite surface. I dropped it, very delicately on the top of my column, and I also applied before that a liberal coat of ink in order to be sure I had some, amount of lubrication, if you will, to prevent my plate from being scratched. And I also, before that, I really heavily stoned the top of the column to be sure there was nothing that could kind of hang on and scratch my plate. So in the picture here, you can kind of see it's hanging off to the left, but really when I dropped it in the middle. The plate is 24 inches and the column is like 34, so really there's only maybe 6 inches that were overhanging on each side. And I carefully moved it back and forth 3 or 4 times. And right when I dropped it, I could feel like the suction was really intense. It was actually really hard to push and move the plate. So right there, I knew I was pretty close to being flat. And that's right before I pick it off the machine. So I had already seen that I had pretty good contact at the top of the column. So I moved it away like that, and I just picked it up. And here you can see kind of the pattern that I got. Again, as I said, that there was a lot of ink on that plate to prevent it from scratching itself on the column. But when I saw that, I knew that I was, pretty flat at this point, and I was pretty happy with this result. So after that, I cut a pattern. I'll just show a quick video of me cutting my last pattern for my colleagues at the office that never seen a hand scraping. They really wanted to see some scraping action, so I'll drop that here. So this is after 2 passes of pattern scraping. I reblued the whole thing with my straight edge this time, and I was pretty happy with that pattern and decided to call it a day. I figured it would be good enough for what this is. But I was pretty happy with these results. So after that, I flipped the machine back on its foot, so I could measure it in the vertical position. Quickly, if I circle back to what I said in the beginning, this is the position in which the laser tracker is going to be the most accurate for this type of work, because basically the laser beam is perpendicular to the surface that I'm measuring. So I measured the overall flatness of the column in that position, and over the whole 34 inches, it came up to be 7/10. So again, pretty happy with that result, but it does show me though that I'm a little bit high at the top and at the bottom. So even though I still think this is acceptable for what I'm doing in that case here, I will pay extra attention on my next pieces to be sure that the very ends are not high. I think this is just due to the nature of using a smaller straight edge. So I'll pay extra care to measure the top and the bottom more thoroughly and make sure they're not higher than the center. After that, I had to measure the dovetails on each side of the column, the gib and the guideway. And in order to do that, I couldn't just use the straight up reflector because there was no line of sight for the tracker to be able to capture everything in one position. So I'll just quickly show you what I came up with in order to measure that.
This is just a piece of C-channel that I chopped one of the ends off. I lapped the bottom surface so it is sufficiently flat to give me like a good writing surface to go on the column. And basically, sorry, I'm doing all of this one-handed, but this goes here. So that gives me 2 points of contact on the gib, and that front plane gives me 3 points of contact. I mean, I could have created 3 pads, but I think the column is sufficiently flat that right now I can use that instead and it's still going to be good. And basically the idea is that now I can slide that up and down, and that's going to measure a line basically on each of these surfaces, and then I can correctly assess if they're straight or not. The spheres are epoxied there. My welder is down, so this is just what I had to do. These are 1-inch ball bearings, and then I just hot glued this flatness on top of there because I want to obviously reuse it somewhere else at some point in time. I didn't want to sacrifice it to this jig here.
So with that tool, I was able to go ahead and measure my 2 dovetails. So you see here gib probe and guide probe. And I also have a second set of these. You see they're called fitted. It's just the same measurement, but with filtering a little bit. So I'll just use these for now because they gave me a better result. Once I had that, I also took this opportunity to probe the main bearing surface of the ram up top. This one is obviously not that used because this is not a part that moves under power. This is basically mostly like a setup surface. But you can see without me doing anything to it, it came up to 8/10 of flatness. So it's only going to require light patterning to just create some texture, but the surface is already pretty flat. And I also took this opportunity to measure the angle between the column and that, because that's one of the criterion. I want this to be perpendicular to the column. So here I have the ram to column angle. You can see this is very, very close to be perpendicular already. The spec calls for 1 thou over 18 inches, and what's easy for me to measure is angle. So basically you can just quickly convert that with basic math. So I'm just doing the tangent of the angle times 18 inches, and this gives me a result in thou. So you can see that the perpendicularity spec between these two, as expressed in the Conley book, is 2/10. So this surface is extremely accurately positioned right now. So seeing that, I kind of decided that I would use this from now on as my second reference. If you remember in the first video, I kind of used the average of the 2 ways to be my second reference for my coordinate system, but I decided that I wanted this surface to be my second reference. So that's that coordinate system 2 here that you can see. So this one, the first reference is the column, second reference is the top of the ram. So then I can start measuring everything else from these 2 references. I also measured the guideway of the ram. You can see it's already pretty straight, 6/10 over the whole length. So that also told me that this was a good reference to use. But basically now, what I need to do, if I look at these 2 lines, I created them nominals that are perfectly aligned with the coordinate system. Same thing I did in the other project. And I will just... So you can see that this one here on the right-hand side is... it's a little off in the top portion, but the bottom portion looks like it's okay. And the whole second surface is a little bit off too, though it's not as bad as the first one. So it basically, this shows me that the bottom of both of these ways is close to be perfect. So when I go ahead and I scrape these ways and I put the machine on its side and all of that, I could use, in theory, the side that I know for now is good and use that as a reference to measure the other one as I'm scraping it. So kind of debating what I'm going to do about that. I'm still not sure. But basically this is where I'm at right now. And while I'm here, I figured I'd kind of show you some color maps too, because they're nice to look at. So let's hide all of that and let's show this scan, because I took this opportunity now that the machine is back on its foot again to scan it, because in that position I can get a very accurate scan of the machine. And I took some time to recreate a color map. Let me just change settings here. So I fine-tuned the color map so it looks just like a scraping. Printing basically. So everything that's white is either high or between 0 and -5/10. So just like on a real, on a real scrape, the high spots are kind of shiny, and then I have a gradient from -5/10 to -15, and then under that I just have like something that looks like the yellow I was using. And I also took the liberty to add a little bit of a depth to the color map. This is something you would not have with a normal rub, but you see I have somewhat of a orange at the very bottom here. So you can see I have a couple of deep spots, but they're, not too prominent on the surface. I took some time to compare that to the actual, let me do that here, so I can overlay in the video. So I took some extra time to compare that to the actual print that I got from my last inking. And this is not reading exactly the same. It still shows me like here in this area, there's a low spot, and here also there's a low spot. I see that on the print too, but this area at the top is not as heavy on my printing. So, what I'm thinking is that the way I'm scanning this is kind of what I thought. Like the scanner has a high enough resolution to capture all the nook and crannies of the surface, but with all measurement devices that use a scanner, the challenge is always how you position that scanner in space as it's acquiring data. There are different types of systems. I'm showing you a tracker in these videos, but there are arms with angular encoder that position the scanners. I could use a handheld scanner that use reference targets all around the part. But basically, that's the main challenge: how you position the scanner in space to not only acquire the data but position it correctly where it belongs. And I think this is kind of why here this is a little bit different than the actual print. But I never intended this project to go this far. I'm actually kind of surprised at how good this is coming out. I wanted to do scanning more for like the macro scale work to kind of put my surface very close to being flat and then use a straight edge. But this shows me that we're almost there. The technology is almost good enough to allow me to straight up use only the scanning for that. So I just want to conclude this video by showing you this color map. This here is kind of a before and after. I'm comparing the current state of the machine to the scan that I gathered last week when I did the initial assessment and the first video that you guys saw. So right now what this actually shows me is how much material I removed, and this is why I have it display like negative values. So you can kind of see in the top corner maybe like the deeper spot, 11 tau, 10 tau, and here about 6 or 5 in the area that was already low. So obviously, once I was getting flat, I kept scraping in order to get rid of all of the scoring and the surface imperfection that I had in that area. So obviously, I went deeper than what I initially planned. But I think it's very interesting because if you compare that color map to what I showed you last week, the shapes are actually very, very similar. So I'm actually very pleased with that because it means that the game plan that I put together last week, I was able to execute it properly and get the result that I was expecting by using the method that I described in this video, using the reference target and realigning to the part and chasing the points and all of that. So I'm very pleased with this result, and it's exciting for what's to come. I think I'm gonna be successful using this method to repair the machine, and eager to get working on it again. So my next step is going to be to repair the ram bearing surface. It only needs light patterning, as I said earlier, but I'm going to start by doing that since I want to use it as a datum reference surface for what's to come. So I want to make sure it is in its final state before I use it to measure any other features. Once this is done, I'll put the machine on its side and scrape the guide and the gibeway of the column. And then we're going to move on to the knee, which I think is going to present much more interesting measurement challenges, making sure everything is square parallels. There's a lot of surfaces on that part to be measured. Okay, so I'll report back when I have some progress, and hope you guys enjoyed the content. So that's going to be it for me today.